The second most common energy source in the United States is nuclear power, right behind fossil fuels.
About 20% of our electricity comes from the splitting of atoms, the same energy that gives the nuclear bomb its destructive force.
As you can imagine, we can get a lot of energy out of nuclear power plants.
But we don't seem eager to use it.
Nuclear power definitely seems to be a bit on the decline at the moment.
This is Derek Muller, host of the excellent science channel Veritasium. He also made a 3-hour documentary for PBS about uranium and nuclear energy, so he should know what he's talking about.
Maybe he can tell us why nuclear power has fallen out of favor.
Yeah, because we used to think it was going to be our energy savior, the chosen one, if you will.
You were the chosen one!
We certainly thought in the past that we were on our way towards a utopian society with lots and lots of energy, but it's not panned out.
So what happened? Why did we think nuclear power was going to be the chosen one, energy-wise?
And how did this amazing scientific breakthrough go down the dark path and become feared by so many? There seems to be a lot of fear surrounding nuclear power these days. And you know what fear leads to?
Fear leads to anger. Anger leads to hate.
Hate leads to suffering.
But it wasn't always like this.
A long time ago, before the dark times, a lot of people thought that nuclear power was going to solve all of our energy problems. In 1954, Lewis Strauss, chairman of the U.S. Atomic Energy Commission, declared that nuclear power would give us energy too cheap to meter.
To me, that quote sounds like the great sort of blustering of a great salesman trying to say, I've got the silver bullet for the future. The truth is, it's much trickier than he wants to make it out to be.
Okay, so Lewis Strauss's prediction never came to pass.
But if you look at how nuclear power works, it does seem like it should be able to solve all of our energy problems.
Yeah, what's the deal?
What is the deal? Broad question, how does nuclear power work? And how do we get energy from atoms?
Yeah, so the big idea with nuclear power is that there are these nuclei which are unstable. A really good one is uranium, and particularly a flavor of uranium called uranium-235. It has 235 protons and neutrons in its nucleus. It is a massive nucleus. It is one of the biggest in existence on Earth. It is so big that the strong force that holds the nucleus together can barely do that. And so what happens if you add an extra neutron is that uranium nucleus rips itself in two. Now in the process, that strong force can get a better grip around those two smaller nuclei, and it gives it an old squeeze. And those, because they've been extra squeezed, are now lighter than the original mass of the U-235. So in the process of fission, in the process of splitting the uranium nucleus, some of its mass is converted to energy.
Okay, so this is where nuclear energy gets really amazing. So you've heard of E equals mc squared, right? The E stands for energy, while way over on the other side of the equation, m is mass and c is the speed of light. Einstein's equation basically tells us that energy and mass are equivalent. And if you look at the equation, energy equals mass times the speed of light, and that's the speed of light squared. So this basically means a little bit of mass will equal a whole lot of energy.
So a tiny pellet of uranium, about the size of like an eraser on the end of a pencil, that contains about as much energy that we can liberate as a whole like train car worth of coal. So it is incredibly, incredibly energy dense, this uranium stuff. And the energy is used to make steam, which turns a turbine, which spins a generator, which makes electrical energy. So that is how a nuclear power plant works, in short.
It seems like every source of power ends up boiling water and turning a turbine. That's what we do.
That's right. They are very, very fancy and expensive kettles. Every single power plant is.
So nuclear power sounds pretty awesome. I can see why people thought it was the chosen one, destined to bring balance to the forces of our energy consumption.
But energy still isn't too cheap to meter, and I don't see nuclear plants all over the place.
About 10% of the world's energy comes from nuclear at the moment, and that's actually down from a peak of 18%, which is back a couple of decades. It had its peak a while ago, and now we're seeing places like Germany close down all of their nuclear power plants because the people don't like the idea of using nuclear power anymore.
Is the general fear the public has of nuclear power, is it justified?
Nuclear power itself, when it runs well, is very, very safe. There's very little radiation that comes away from a plant. In fact, you're exposed to less radiation living near a nuclear plant than you are living near a coal plant. That's because when you burn coal, there are some radioactive atoms in that coal, and they get released in the atmosphere. So nuclear actually, ironically, exposes you to less radiation than a lot of other forms of energy generation.
In fact, a 2014 study by the Clean Air Task Force attributes 7,500 deaths a year in the US to fine particle pollution from coal plants. And that's when they're working properly.
True, people have died as a result of radiation from nuclear power plants, but the number is much smaller than coal, and it only happens when something goes wrong. And nuclear plants don't give off any carbon dioxide, so they don't contribute to climate change at all.
So really, nuclear power is way more environmentally friendly than fossil fuels, from a certain point of view.
Back in Lewis Strauss's day, we even thought that nuclear power was destined to eliminate fossil fuels.
But that didn't happen. For one thing, nuclear power plants are expensive. When we first started building them in the 1950s, half of them were abandoned before they were finished because they turned out to be so costly. While the operating costs of nuclear are less than coal, the initial cost of building a plant is quite a bit more.
For one thing, you need to keep all the radiation in, so you have to have a lot of security or a lot of insulation around the reactor. Everything becomes radioactive over a period of years, so basically by 25 years, 30 years, 40 years, that whole plant has become radioactive and needs to be very carefully decommissioned. And then of course there are security concerns around people getting into a nuclear power plant, getting access to nuclear material. You gotta store the waste somewhere.
That waste, along with all those radioactive parts from the decommissioned plant, has to be buried deep inside the earth in a specialized facility, far, far away from people.
And that waste could remain radioactive for thousands of years.
But it's not just the logistics of nuclear power that makes it hard to implement, it's also our fear of it. And you know what fear leads to.
Around the same time Lewis Strauss was selling the benefits of nuclear power, the general public was learning a lot about its dark side. The US and the Soviet Union were engaged in nuclear tests all over the world. Although these bombs were meant to be tested in remote locations, unpredictable weather conditions and the unknown nature of the bombs themselves led to a few highly publicized accidents where people, ships, and entire villages were subjected to radioactive fallout. And these incidents began to inspire movies where radiation and nuclear power gave rise to monsters.
This did not help nuclear's public image.
And then there's the possibility of a reactor meltdown.
But that hardly ever happens, right? Right?
For as many times as we want to say it'll never happen, it's one of those things that history has shown us it can happen, and it's like it happens in the least probable ways.
In 1986, the Chernobyl reactor in the Soviet Union exploded, spreading a cloud of radiation and fallout all over the USSR and Europe. It's the worst nuclear accident in history. 31 people died in the incident, and many more later from cancer due to radiation. Estimates of the number of casualties vary wildly. Some reports put the number at around 4,000, but the full impact is still unknown.
But after Chernobyl, I think everyone got the sense that this could never happen again, that it was cheap manufacturing with poor thoughts about safety, and never in a Western country would we expect to see something like that happen again. And then you had what were a terrible set of circumstances in Japan.
In 2011, a 9.0 magnitude earthquake off the coast of Japan caused a tsunami that hit the Fukushima nuclear plant. Damage from the tsunami led to a failure in the plant's cooling system, causing explosions that spread radiation all over the area. Many communities near the plant were forced to evacuate, and most of them remain empty today.
Something interesting that I found in Japan was that there have been no deaths, right, in Fukushima due to radiation poisoning. However, there have been a lot of deaths and a lot of ripped apart lives from the event, from the fact that they had to evacuate their homes, from the fact that there's loss of community, loss of jobs, they can't go back to where they used to live. What's really interesting is that fear of nuclear is not something that you can just push aside and say, well, that's just people behaving irrationally, because it has real impacts on their lives. So that is one of those things that I think we should all consider. Ultimately, I think we should make our decisions in a much more informed way, and that is the point of making this documentary, so everyone understands what nuclear really is, where it comes from, how it works, what it's good for, and what it's not.
Okay, so maybe our fears of nuclear power aren't completely unjustified.
And it hasn't given us electricity that's too cheap to meter.
But what if Lewis Strauss wasn't talking about nuclear fission? What if he was talking about nuclear fusion? This is how the sun works. The sun is a huge nuclear furnace, but instead of using nuclear fission, splitting atoms apart, like a nuclear power plant, it does the opposite, taking atoms and fusing them together.
You can get a lot of energy out of this. The amount of energy you can get per gram from a fusion reaction can be over 10 times greater than an equivalent fission reaction.
Just look at the sun and every star in the sky. They are all fusion power plants. And there's still a chance nuclear power might vanquish the dark side, fossil fuels, and bring balance to our energy needs. A new hope, you might say.
So Lewis Strauss might not be wrong. He just jumped the gun a little bit. The kind of nuclear power he was talking about doesn't exist on Earth. Yet.
Scientists have been trying to achieve fusion for like a century, and we have not got there yet. However, we are getting very, very close. The really hard part about fusion is getting more energy out than you put in the first place. You have to put in a lot of energy to get these particles so hot that they won't avoid each other anymore, and they'll actually collide with each other and stick. That takes a lot of energy.
But are we going to do it?
I think that we will get fusion at some point, but it may not be in the near future. It may take at least 10, probably 20 or 30 years. I mean, right now we have a giant fusion reactor, it just doesn't happen to be on Earth. But we could use its energy using something like, say, a solar panel, and then it's like we're using the power of fusion, but we don't even have to make the fusion ourselves.
Yeah, so fusion technology seems to be a ways off from being a reality. But in the meantime, maybe we should be making more use of the gigantic fusion reactor we already have.
Yeah, set up a bunch of solar panels, and then we can finally have the electricity that's too cheap to meter. And then it's hot pockets every meal of the day.
Yeah.
Double up.
Just put them in my mouth, full of them.
I think it's really difficult to make predictions about the future. And I'm always hesitant to make the same prediction that someone else has made like 50 years ago and then looked really dumb for making that prediction. So the point I would make is that energy is stupidly cheap, right? Like 1 kilowatt hour, that only costs about 10 or 12 cents in a lot of places like the US. I mean, to me, it almost is too cheap to meter. Except it's not, and we use a lot of energy, so it's still expensive. You know, there's like 1 billion people right now who don't even have access to electricity. So I think we're going to get more energy out to more people, which will raise the standards of living of everyone in the world. And I think we'll find cheaper and cleaner ways to do it. Like anything, it's going to come with challenges, but I don't think, you know, there's a simple silver bullet answer to the future of energy, but I think we're going to get there, and I think we're already on the right track, and I like it.